Okay, we can start. First of all, we will cover about the index. Yeah, these are the topics we have to cover. Means, let's say what is the index, then why it is required, then how to apply the index on table, then different types of indexes, right? There is a clustered index, non-clustered index, right? And one by one we will cover. Okay. So first of all, index, right? So index is nothing but the a searching thing. Means, let's say there is a object in the database, or first of all there is a database, and in database there is a tables and index, and there are constraint keys, multiple factors, correct? But who is occupying the space? First is the table data, and second is the index one, correct? And in, means, suppose you have a one book and you have to and it books contain multiple chapters, let's say 8 chapters or 10 chapters, it's fine. But if that books it is a having a lot more pages, means let's say 5,000 pages, and it contains the hundreds of chapters, then how you can find that particular chapter with the help of index page? Means it contains that particular, means book having a, first of all there is an index, and it the they mention in index there is a chapter name as well as page number, so that you can easily go on that page and you will get that data means whatever the chapter name plus its details, right? So same thing it apply in the database, means that why index is came into picture. And next thing, one bit is equal to 0 or 1, means there is a single bit, then nibble, right? And after that there is a 1 byte, means 8 bit. So, and page size is a 8 KB, means it is the default size of the page in the SQL server. Okay, so first of all I'm going to in Excel so that you can get easily that things. First of all I'm copy it here. And okay, when we are creating the table, right? Let's say first one is the database, right? Database contain the table, and table having the indexes, okay? And only these two objects occupying the space in the database, okay? And after that, when there is a table is created, on top of that we are creating the index for the fast search. Means, yeah, I will going to there, means in the index topic I am, let's say, assuming 50. Okay. And salary is the big integer. Okay. And in that ID is 1. Then name is, let's say, Sagar. And then salary is 50,000. Okay. First of all, how data is stored in the SQL server. So as we know, 8 KB is the page size, right? And we have to store this data, right? So means here there is a schema, means this is the table schema. It definitely it is the metadata, means it contains having some data. So it occupy some memory in the database, obviously. Means there are the table indexes, then there is a objects are nothing but the, means, stored procedure function, then trigger. These are the some objects, they are also occupying the some space in the database, but very minimal. But more space is occupied by the table and index, okay? And here I'm going to discuss with you about the table space, means how that data is going to be stored. And then on top of that we are creating the index. I am directly going to the index. Yeah, what is this index, and just going through the PPT. So it will hard. Be- instead of that, I'm going to explain you about the um, from basic. Okay. So yeah, we have to maintain this information in the form of 8 KB page. So let's say there is a ID integer. It integer how many bytes we have to store. There is a, let's say, 4 bytes. Okay, in the background. means as you know there is a teeny int. These are the data types: teeny int, then integer, then big integer, right? And then again one there is a small int. Control X. Okay, small int. So means 1 byte, 2 byte, 4 byte, and 8 byte, right? So and this is the means let's say this one cell occupy 1 byte information. Okay, let's assume 1 byte. And how many bytes it occupies? There is a 1. So it occupy there is a 4 bytes. Okay, and this is the ID. Means this complete cell occupied by the id column means there is a value as 1. And then next thing is that Sagar. So Sagar, how much characters? There are 5 characters. So and we are setting it as a 50 characters maximum length, so it will occupy 5 bytes. So I am considering the 5 bytes for the this Sagar word, right? And then next thing, what is that? uh 50,000 salary. So I'm assuming means there is a big integer means 8 bytes, right? So 8 bytes means the 50,000. So 1 2 3 4, and these are the, yes, these are the 8 bytes, right? So these 8 bytes are occupied by the salary as a 50,000. Means data is stored in the leaf page in such orders, means 1 Sagar, then 50,000. And when on top of that, when we are creating the primary key, means here on id column, or let's say means here is the we are creating the primary key column, or means there is a, in MySQL there is auto increment, in SQL Server there is a identity, and simultaneously we are doing that thing with the help of the means while creating the primary key in the background there is a clustered index is created. Why? Because to means it determine the physical order of that particular table. Means let's say here is the employee is the column, right? And I'm yeah, I'm making it as a yes. Here there is a one, then after that two, three, right? These are the three different names. Yeah, and salary, something like that. Okay, so these are the different data we have to store in the tables. And one by one they are we are inserting the data, we are modifying the data, then after that we are deleting the data. Means these are the rows are storing one by one, means the leaf pages are fill one by one here. And once the record is filled, then based on the primary key, means here we are assuming, yeah, this is the primary key, so based on that the SQL server storing your data in the background. Okay, means let's say there are hundreds of records in the table and you have to find the means one record or a 10 records, then how to find? With the help of index it will be a very useful. Means as we seen, data is stored in the format of means 8 KB pages, means lip level pages. If I have to show you the PPT, and then there is a key values, means there is a key values, and after that these are the root level, then intermediate level, and these are the lip level pages. Means your data is stored in the form of lip level pages. And as I said, it determine the physical order of the table. Means when we are creating the clustered index, so how to store the data? Yeah, based on the some order. Means based on, suppose you are creating the primary key on the id column, so on that order SQL server is going to insert the data. Here is a 10th record, so it will accept that, no problem. But when we are applying the primary key, or in the background there is a cluster key it's applied, then it is sorting that things and then storing it here. First of all I will show you one simple example here. Let's say these are the three values, right? And sorry, this is the table creation, means create table emp, and I didn't created any primary key, or means on that particular unique key. Means when we are creating the primary key, clustered index will create in the background, and if we want to create the primary key on another column and clustered index on another column, that should be a possible. There is no any problem, and you can create the unique key as well. And if you are setting up the identity 1 comma 1, so that will increment by one, and data is going to be insert, but in the background there is a nothing index will apply. Okay, so I'm just basically inserting the data right here. So instead of the decimal, I'm making it as a, and yeah, create table, then insert the 5 records. And yeah, if you are going to search the data, select star from emp, so you will get 3 records, right? And how that data is stored in the table, so it is basically based on the 150 55, and let's say I'm going to insert another 2 records, right? Which is the means here is the I'm giving the fifth and sixth, Manoj and Sunil. Okay, so these 2 records I'm going to insert. Yeah, the value may be different. If you are going to select star from, so it is saving the data in terms of the 150 55 5 6. Okay, so here what I have to do, I have to create the clustered index. So how to create the clustered index? So create index name, create clustered index, and the syntax is ix underscore, yeah, table name. Who is the table name? Yeah, emp, and then there is a column name is id. Okay, and then on table name emp, that's it. And on which column we have to insert id, right? Means we are creating the clustered index on the id column. So what is the, yeah, before of this is the structure, means 150 55 5 and 6. And when we are, yeah, emp id should be instead of the id. Okay, so I'm going to create the clustered index, and I'm going to enable the execution plan. So if you see execution plan, what is happening means there is a table scan happen, means 5 rows it scanned, and after that there is a sorting operation done. Means in the background they sorted the what are the things inside the that particular table, and then it scans and then sort, and then it created the index, right? And when you are going to select star from emp again, so you will get in a one order. Means previously there is a 150 55 5 and 6, but right now it is a different. Why? It is basically dependent on the clustered index. Means if you are setting up the clustered index on another column, so that is the ascending order or a descending order. Based on that, your data is stored in the lib pages on the column as you specified. Means if we have to create the clustered index on another column and primary key on another column, that can be possible. Yes, that can be possible. Means with the help of unique clustered word, we can use that. So first of all, I am dropping the existing clustered index. Okay, drop index name on table name. So we are dropping the index, right? And yeah, right now you can see there is a select star from emp, data is shuffled, but right now they are in a sorted order, means 156, because we dropped, but still there is a in background data is shuffled. And right now what we have to do, our next objective is we have to create the primary key on emp id column and clustered index on the name column. Okay, first of all we have to apply primary key, right? But when we are creating the primary key, in background cluster index will create, right? So how to avoid that? So we have to use the unique clustered word, primary key. First of all, I'm going to drop the table, drop table emp. So what it does actually, if you see the Alt F1 on this, then you can see there is a primary key on another column and clustered index is on another column. Means primary key on emp, there is a emp id column, and unique clustered is on name column. And then next thing is that, yeah, why it is required to search the data very quickly from the database. Okay, and it takes the space in the database, and it is organized in a B-tree fashion. Means there is a 1 to 100, then 1 to 50 records at the left side, then 51 to at the right side. After that, 51 to 75 left, and then right. Means we can fetch the data quickly. Okay, so first of all, I have to show the exact information from this table database. Select star from patient. Yeah, let's see. It contains, I think, 1 million record. Select count of one from patient. So yeah, here there is a row count, means 1 million something, right? 11 lakh 90,001. And if I'm going to search, where right now, first of all, we can check, yeah, there is a any index available on that table or not. Yeah, there is a primary key index available on patient id, right? And I'm going to drop this index because I created before. Drop index name on table name. Okay, we dropped the index, right? And let's say here I'm going to search first name is equal to, select top 10 star. Okay, so there are 1 million record, correct? And 1 million record, we have to search the data who having the name as pf name underscore 9. Okay, execute the query. And in the background, I am checking the execution plan as well. Means here, what that execution plan is saying, yeah, clustered index scan. Okay, and how much records is estimated number of rows to be read. Yeah, you can see there is a bottom fourth. Okay, and then I'm going to create the index on it, right? Create index, index name on table name patient. Okay, and which column? So first name, right? Execute it. So in the background, it does the sorting and then applying the index. And let's see, yeah, if you are going to select the query and enable the execution plan and then execute it. So execution is plan is saying, yeah, how much rows, yeah, estimated number of rows to be read as a only one. And you can see estimated IO cost, estimated operation cost, then there is a CPU cost. So yeah, and why here there is a key lookup means it grab all the data, means all the columns. Star means all the columns, right? And you are taking up only one column, or means there is a first name. Okay, then there is a, yeah, let's see, first of all here, and select star. Okay, what is the difference in between this execution plan? So it is the only indexing because it taking that particular value and showing to the user, and here there is a it goes to the particular record pointer, means where that record is stored, and it gather all the data and showing in front of you. Okay, so and you have to show, yeah, here there is a keylookup occur. Keylookup is the just which point to that particular record, and we are getting the complete whole record value, correct? And there is a indexing. I'm giving the print screen, and yes, you can see. Um okay, if you compare these two, then what is the difference in between these? Yeah, here you can see there is a 11. Sorry, I am going to zoom it. Yeah, so here you can see there is a 11, means 11 lakh records, and here you can see there is a estimated number of rows to be read as a one, only one record. And you can see there is a, yeah, IO cost is 0.0303, and here is the 34%, right, IO cost. And it is the too heavy, right, because it scan all the entire table. And suppose let's say any table, and that table does not have any index, such a table we can call is at a heap table, means here is the employee table, right? So there is a no any indexes on it. So first of all, I'm plain table, yeah, making a plain, yeah, and creating it. And there is a, we are inserting 6 records, yeah, 5 records, and then select star from emp. So this is the small table, it's fine. But in the background, if you see, uh, there is a table scan operation is done. Table scan operation, it means it scan entire data, and such a table we can call it as a heap table. Okay, and here there is a select star from patient. So if you are going to fetch the data from, let's say, top 10 patient, and you want to filter the data date of birth wise, gender wise, or address line wise. So basically you want to add one index over there. Means suppose there is a frequently searching from UI side, there is a first name is this, last name is this, and yeah, gender is this, or a city belong to this. So in this case you have to apply one index in the background. And what it does, actually index is the, as I said, there is a root level and intermediate level, and there is a, in the leaf level there is a data. Okay, so what I have to explain you about the non-clustered index. Non-clustered index contains the data, means actual, first of all I'm going to create about the clustered index contain the leaf pages and having the actual data. But non-clustered index contain the key value and row locator. Row locator, it means, let's say, here is the, first of all we created the here small example, right? Non-clustered index we created, I think here, yeah, I'm going to close it here. And on patient we created the, on first name, because already patient having the clustered index, right? So what is the non-clustered index? We created the index, this is the non-clustered index. How to see, there is a press on a patient and alt F1, so you will get number of indexes, right? And yeah, I'm going to because execution plan, yeah, it will take too much time. So yes, here is the you can see non-clustered located on a primary, and this is the clustered index unique primary key available on the patient ID, right? And means it contains the name, means whatever the name, and it contains the their row locator. Row locator, it means the where that record is stored, right? uh, yeah, I want to show you two cases at here for the non-clustered index. Means one case is with primary key, and second case is first case, and second case without primary key. First case is a primary key, means patient ID is the primary, correct? So and we have created the index on the name column, so name and patient ID, there is a separate block is created, so that if we search, yeah, patient name is equal to pf name 19, and the patient ID, what is the patient ID of that particular uh, uh, 9, correct? So it will directly go to that particular 9, and 9 contains the complete information, exact row, means complete information about the row in that particular patient ID, means clustered index. And second thing is that suppose that particular table does not have any index, means, and we are directly creating the non-clustered index on the first name, so it does not have the clustered index, so it will go to the row locator. Row locator means where that record is stored, means hexadecimal address of that particular row that contains, means name plus hex address. Okay, these are the two things in the background for the non-clustered index. Got it? Means first of all, means clustered index contains the data, or the lib, means it contains the lib pages, and lib pages contain the data, right? And but non-clustered, there is a key value and row locator. And row locator is in terms of the primary key, there is a primary key itself. If there is a no any primary key on the table itself, then we are storing the hex address. And in non-clustered index, there are multiple subtypes as well, right? Here there is a unique covering, unique index, covering index, composite, filtered, xml, spatial. Yeah, we will go through one by one, but are you clear this point? Means what is the clustered, what is the non-clustered? Actually, yeah, I am sorry for that, means I'm confused while creating the clustered index and switching the means clustered plus primary key. So that the position means I was jumbled, but right now, yeah, all the things are fine now, I think. Please could you give me the answer as a yes or no in the message box? Hi, are you there? Okay, I'm not getting any answer from your side. Okay, yeah. Then next thing is that, yeah, miss clustered and non-clustered index is created, and miss why we are creating the clustered, because to searching the data very quickly. Okay, and non-clustered index, yeah, it is another miss sub miss which is helping for the searching, and which is having the less speed as compared to the clustered index. I have to show you one slide, means here there is a difference between the clustered index and non-clustered index. This is the clustered, means for one table we can create the mm, one clustered index, but we can create the 999 non-clustered index per table. Why? Because, yeah, means in interview, interviewer may be asked, yeah, why we can create the only one clustered per in table? Because it determines the physical order of the table, means either ascending or descending. Based on that, we are storing the data in the table, right? So that's why only one clustered is required, not more than that. And then non-clustered index, yeah, we can create 999 indexes. And yes, there is a one more thing. Yeah, I will show you in terms of the composite index. Means we can include multiple columns. Means let's say first name, then last name. So such a index are called as a composite index. So I will, yeah, come to this point. And then maximum it contains the 16 column. So yeah, I am remembering this. Yeah, and here is the index id. When we are creating the clustered index na, then at that time there is a clustered index id always be 0, and non-clustered index id is greater than 0. And then there is a performance wise, yeah, as we seen, there is a performance wise always clustered index is fast because it contains the actual data, and non-clustered index are slow because it driving the data. Means first of all it come to the means here in this example there is a first of all name it will check, and then again it will go to the patient id, or it will first of all finding the name. Yeah, first name is this and hex address is this. Means it will jumping to the another means either it's a clustering key or a hex address. That's why it is a little bit slow. And yeah, it contains the data pages, or as I said, yeah, clustering key or a pointer to the row, means hex address, right? And we can create the non-clustered index on a table it having or not having clustered index. Yeah, this example also we seen. Means uh, suppose we can, means there is a no any uh, thumb rule that we have a primary key or a clustered index on the column. We can directly create the non-clustered index on that particular table. Okay, means it is not mandatory that table have a clustered index or a primary key. Okay, and 1 minute. Yeah, sorry. So as we seen, yeah, then next thing, yeah, syntax wise we can see here is the for while creating the primary key we can create the clustered index in the background, or we have to apply the clustered word, then we can use that word. Or after the creation of the table you can also create the clustered index. Okay, how to do that? Means there are multiple ways. If you go on my blog, then it will give you all the answers. Means can we create the more than one clustered index on table? Can clustered index allow duplicate value? Can clustered index allow null value? So you will get, but you have to do some practice on it, then you can realize, yeah, these are the some things we have to try. Okay, and where are we? Yeah, so I have to show you mm, drop table emp. Okay, and this is the create, means we creating a table, right? Emp table, and after that we have to create the clustered index. So how to do that? Yeah, just simple word as a create clustered index name. I am showing it as a id on, yeah, patient id, sorry, emp id. Okay, so this is the simple syntax, right? Or and in terms of the non-clustered index, you can see here there is a, you can use non-clustered index as it is, or without, if you not mention any non-clustered word, then automatically it will create the non-clustered index in the background. Okay, so these are the syntax wise, and yeah, we seen the definition, maximum node, yeah, maximum indexes. So then we are going to the types of indexes, right? Means unique index, covering index. So one by one we can see. first of all, unique index. So suppose what is the scenario behind the unique index? There is a one column means like a Aadhaar card number or a social security number. We have to make it as a unique. So when you make it as a unique, at that time in the background, unique non-clustered index will create. Okay, and here when you define the unique constraint, the SQL server automatically create the non-clustered index in the background. Okay, means here is the EMP ID, and we are saying it as a unique, so it won't allow. Means let's say I'm showing you practically. Yeah, my table, and if you see, uh, press Alt F1, so in background you can see there is a unique non-clustered index will create. Okay, and there is a emp id. So that is the thing, means when you apply the unique word, then unique non-clustered index will create. And if you say unique clustered, then clustered unique uh, clustered index will create. Okay, and why it is required? Because while creating the primary key on another column and clustered index on another column, in that situation you have to use the unique clustered word, otherwise no. And this is the unique, means we are specifying the emp id column as a unique. Why? Because we have to maintain the unique value in the emp id, or we can say other card number. That is the good example, means it is the uniquely identifying one. Or we can create the unique index with the help of this word, means there is a after the table creation, then you can specify. First of all, I am dropping this table, or you can drop the index as well first. That is also possible. Okay, and here there is a unique clustered word I used. Yeah, previously I explained you, and while creating the table. So first of all, create the table and create the unique index. Okay, so I'm going to select all. Yeah, what it does actually, it is the emp id and emp name. These are the simple columns. Okay, and we didn't created any index anything, right? And I'm going to create unique index. So here unique word is important while creating the unique index. Okay, and yes, so what it does actually, it determine means uniqueness in the emp id column, and then after that we have to drop, then you can easily drop. Suppose, yeah, for example wise, yeah, here execution plan, that's why it is saying as a execution two rows. So if I'm going to execute again, say same thing, means one on, or let's say there is a emp id, we make it as a unique, and if we are making it as two, then it can be possible. Okay, because we made this emp id as a unique, that's why unique. Either you can enforce the unique word at here, or you can create the unique index at here. Both can be possible, means you can maintain the uniqueness of the column. Okay, and next thing is that covering index. Okay, so why covering index is the very important, right? Means from when we are creating the uh, actual stored procedure, or store function on, we are grabbing the data from multiple tables, and while retrieving the data at that time, we are uh, applying the index on one column, and we are retrieving the number of columns from the different tables, right? And there is a situation means in instead of the star we required some specific column. So how to include that column in the that particular select clause? So that is nothing but the covering index. So yeah, I'm going to explain you practically so you can easily understand. First of all, yeah, this is the syntax means create index name on table name. But here is the include clause, it's come into the picture, and here is the where clause list, right? And uh, I have to show you practically, and then we will go through the theory, means so that you can understand the theory easily. Let's say here is the patient table, or I'm grabbing the one query from my blog. Here is the HIMS project, and there is some select queries are over here. Um, okay, and I'm just taking a very simple sample. Okay, yeah, I actually it is the aggregated ones. Uh, and my objective here is I want visit date means that particular year in 2022 how many patient count with the help of department means in that particular year 2022 year, and there are multiple departments and department wise visit count I want. Okay, so it is the query, right? So it will give us the query in fraction of second, no problem. But yeah, there is a means detailed data, it means this is the aggregated data means we used aggregated function means count, and then there is a group by we used, right? So instead of that I want the rows of particular means here there is a patient visit, then there is a doctor and department. I want v dot visit id. Yes, and then visit date, right? I'm going to explain you covering index, but yeah, these are the some necessary things we have to require. Yeah, visit table, and from visit table only we require only two columns, means visit ID and visit date. And instead of the creating means, and after that we have to filter on the visit date as well, right? So yeah, I will show you. And after that in department there is a department name. Okay, d dot. Okay, here is the dp dot name. Okay, and then next thing is that doctor. Okay, d dot first name thing. Yeah, first name comma last name. Even if we can add the patient as well, means joining the patient as well. But yeah, this is the detailed data, right? 6,900 records is here. And if you see the execution plan, then there is a miss, it is showing as a number of rows to be read, because in doctor there are only 60 records, that's why. And then there is a indexing is where occurred. Yeah, there is a department and doctor. Okay, and there is a clustered index scan, right? Here is the clustered index scan, how many records are scanned here? Only number of rows to be read 8,054. Okay, and I want the complete year of visit date. means entire data of the visit table. So only, yeah, these are the 8054 records only. So we required large data. But okay, I have to show you, yeah, instead of the, here is the clustered index scanning is happening, right? And then here primary key index on visit table, we are uh, means fetching only two columns from the visit table. There is a visit ID and visit date, right? So if we apply right now, this is not the concern, means here there is a showing as a visit and visit date, yes, but doctor ID is included here, means it showing as a please include the doctor ID so that it will perform the best. So such a index are called as a, means where there is a include is come into the picture, then such a indexes are called as a covering index. Okay, and let's say here I'm going to include or any other example, let's say visit, and I'm just removing all the joins, and based on the visit I want to retrieve the data, visit ID and visit date 8054 only. Okay, clustered index scan, and there is a, if we have to make conversion into the clustered index scan into the clustered index seek. So how to do that? So create index. First of all, we have to, yeah, this is the symbol, means syntax, create index name. I'm just copying it instead of wasting the time. Yeah, okay, ix visit, and then table name is a visit, and um, where clause. Yeah, where clause, it means, yeah, on which column we are filtering the data. Okay, so based on the visit date is equal to, first of all, yeah, there is a 6 2. So if you search it, then in execution clustered index scan is, and it scan the 8054 records. Okay, so we have to convert it into the clustered index scan to the clustered index seek. Okay, so first of all I am making the print screen first. Yes, and then I'm going to cover here on which column where clause. Okay, so on, we are searching the data on the basis of visit date, right? And include, yeah, which column we are going to select, means in select we are adding visit ID and visit date. Visit date is already available in the filter. Okay, so don't need to apply here, and instead of means again, there is a visit ID is the primary key, right? And so it will automatically means if we apply the same plain index, so it is going to convert into the indexing. If you apply it, execute it, and then yeah, you can select it. So in execution plan, indexing is occurred in here. There is only one row is number of rows to be read, only one, correct? So yeah, you can see there is a 8054, and yeah, I have to show you the difference in between them. Here you can see there is a 8054, right? And here is the only one row. And one more thing, suppose I include two more column at here, means v dot means visit, then there are different columns. uh, First of all, yeah, I'm just exploring it. there is a patient ID. Okay, and then there is a unit ID. Okay, so if you selecting it, then what it does, actually there is a index seek operation is called, and there is a key lookup occur. Key lookup occur, it means there is a, first of all it will find the record based on the visit date, and then what it does, it will go to the primary key, and based on that primary key it bring all the data, means visit id, visit date, patient id, entire records will capture with the help of key lookup. Correct, and then we are getting the data, and I have to convert this, I have to avoid this thing, means into the clustered indexing. So how to do that? So first of all I am paste at here, and okay, I'm going to consider, yeah, include clause, control Z, include, and patient ID and unit ID, because uh, here visit ID is the primary key. It already have, means here there is a non-clustered index ix underscore visit. So based on the visit date, it will automatically calculate that, means it will bring that particular record, and then visit ID it contains already. So that's why it is the indexing operation is done, and key lookup operation is happen because of the patient ID and unit ID, right? And if we considered that columns in a include clause, then the uh, structure will change, means there is a clustered indexing operation, and here is the, you can see there is a in bracket, there is a non-clustered. Okay, so if we see covering, okay, this is the covering index, and then create it. Okay, and then again going to check, yeah, you can see the execution plan, yeah, indexing it's called, right? And here you can see there is a nothing lookup occur, means it, that particular index contains the data about the patient id and unit id, means what is the filter, visit date. Okay, and where is the row located, means it having the primary key, so there is a row locator. First of all key, then a row locator, it means clustering key, because it having the primary key. Okay, and then third one is the mm, yeah, these are the optional. Optional, it means it contains the data covering index. There is a pk, and here is the these two columns, patient id and unit id. So it won't miss, first of all visit date, and based on the visit date it will get the data, and it will get the data, and it is going to the primary key, right, in the previous operation, means in this operation. But when we apply this key, it will not go to the particular primary key, it will go to the here, yeah, I have a visit id, then visit id, visit date I have, then patient id I have, and unit id I have, so why to go there? So key lookup operation is avoid. Okay, and in multiple cases, yeah, you can see, yeah, covering index will be better, means we have to avoid the lookup. Then at that time, means there is a some joins condition, I am, yeah, I am just making a simple query at here, but in some scenario there is a very, means multiple joins, there are 5 to 6 tables are joins, then we are grabbing the data from multiple tables, and we have to select the data, proper data, right? So at that time covering index is a very helpful to select the proper data, means instead of the, to avoid the key lookup. Okay, or a row lookup as well. Key lookup, row lookup, these are the two things. Key lookup means this is the key lookup occur previously. If you see closely, yeah, in paint, yeah, you can see there is a yeah, key lookup occur. Key lookup occur means it go to the clustered index, means primary key, and that's why it is the key lookup. If that particular table don't have any primary key, then there is a row lookup. These are the execution plan basics operator. And yeah, third one is the, we can see execution plan of it. And yeah, I am, suppose that particular table having 50 columns or 100 columns, and in that situation this will be a very helpful. In small table, yeah, this is the small, means you can see there is the all the things are similar, there is a not much more difference. But for different, means there is a, if you are table having the uh, means there is a raw data or a n varchar max column, so exclude that n varchar max columns. Means there is a, let's say, 50 columns. Out of 50 columns there are, you are selecting only two columns or three columns, then in that case covering index will be helpful, because you are grabbing the only three columns data, right? So yeah, it will store that particular three columns data in the that particular index, and we will get the data very quickly. Once ER means this is not going to the primary key and then entire row index, the entire row will read. So it means restrict that operation and directly getting the data from the patient ID and unit ID from it contains it already having that data. Okay, and then next thing is that composite index. Okay, so composite index, what it means, let's say here, first of all, I have a ready example for that. Means I hope you got the theoretical covering index. Means theoretical point, biggest benefit of the covering index is that it contains all the fields required by the query. Means suppose that particular table having the 10 columns, and you are including the 9 columns, so this is not the good idea. Only two columns or three columns we have to include, then this is the good idea from performance point of view. Okay, and yeah, these are the some things, means I already explained you. And simple execution plan below. Okay, then next thing is the composite index. So composite index is one, means suppose let's say there is a simple example I have to take, taking this example. Means here is the composite index is the table, there is a, I am calling it as a name. Okay, and there is a varchar 100 and column 1, column 2, column 3. Means suppose we have to apply the index on a 3 columns or a 2 columns, then we are calling the such a index are called as a composite index. Composite index, it means there is a, let's say here is the primary key on these columns, and we are creating the one index. Means there is a column 1, column 2, column 3, create index. I'm just, yeah, ix name, column 1, column 2, and column 3. Means this is the simple, means you have to just create the create index name on table name, and here these are the columns you have to mention. Means instead of there is a last name, first name, last name, middle name, so this is nothing but the one order, right? So this column is called as a leading column. Means when we are retrieving the data from the table, uh, where the query will be like select star from composite index, correct, where column 1 is equal to 5 because 5 is the integer, that's why. And then column 2 is equal to xyz, and column 3 is equal to this xyz. Okay, so in such a situation this index will be helpful, means composite index. Got it? And yeah, if you can see right now there is a no data is inserted, but in a execution plan, yeah, you can see there is a clustered index scan only one row, because there is a that table does not have any data. And means here we mentioned there is a star as well. If you mention there is a id only, then, and here we didn't mention the prime, yeah, here is the primary key clustered index we mentioned. Yeah, suppose the execution plan, yeah, clustered index is called because uh, here id name or a star, it means it grab all the data, that's why there is a scan is happened. And I have to show you basic example after this. First of all, yeah, we will go through the filter index. And means, are you clear about the composite index? Means whenever there is a combination of multiple columns in one index, then such an index we can call it as a composite index. And which is basically called when there is a such means same order, means when you are filtering the column 1, column 2, column 3, at that time such an index will call, and exactly you will get the data, correct? And if you wanna avoid that particular, means right now I am making it as a star, and I have to make here there is a clustered index scan operation is done, right? Clustered index scan means uh, it scan the entire index, right? And then we will get the data, but you have to make it as a means from performance point of view star is not means actually we have to avoid that things. Means if we are interested in two columns, then why we are using the star, right? So we are using the id or a name. And in this situation, which index will call? Here there is a clustered index scan, because there is a for name, it will go to the uh, that particular row and we will get the data, right? And if we include that name in a name clause, then that will be a include name. I am going to draw previous index, or yeah, I will create one here. Create, this is the covering index, and if you see, then there is a clustered index seek. Okay, so this is the some small changes we have to apply, means what we are selecting over, so that we have to add the in include clause, so we can convert it from the clustered index scan to the seek. And only three operations basically: table scan, means it scan the entire table, there is a no any indexes on the table, then such a table, means we have to filter the data, right? So in the background there is a table scan we happen, and such a table we can call it as a heap table. Okay, and then what is mean by index scan? Index scan is nothing but the index is scanning from entire index, means suppose that particular index having the 10 rows or 15 rows, so entire index will be scanned. And in indexing, so indexing is the very important thing, and from performance point of view, indexing is required to get the actual data, or and miss very quickly. That is the purpose behind of the indexing. Okay, and after that, yeah, XML index and special index. When there is a XML data we are going to store in the SQL Server table, there is a XML data type, correct? So at that time, XML index we can use. There is a primary XML, then secondary XML indexes, and then there is a special indexes. Special indexes are when to use the special indexes, when there is a such a type of data means geometrical data, latitude data, so at that time we can use the special indexes. Okay, and the column store index, what is meant by column store? Actually, column store index, I have to give you the one scenario. Then column store index, we can use it in the OLAP system, or we can call it as a data warehouse. And when there is a large amount of data, at that time we can use the column store index. And how it will help us in the to for the better performance? First of all, there is a one table in HIMS, select a star from charge. Okay, so it contains the numeric value, means when we have to do any aggregation on, suppose let's say, on amount or a rate, so there is a aggregation is required, sum, count, mean, max. So at that time, right now the table contain only 51,000 records. Yeah, it is a very small, means when we are dealing with the large database, means 2 TB 3 TB databases, and that table having the billion or a millions of rows. So at that time, means from reporting perspective, column store index will be helpful. How? Yeah, first of all, I'm showing you a small example. Let's say visit id, I'm going to add order by visit id. So I have to check, yeah, is any, yeah, okay. Previous structure was different, means for non-clustered index and clustered index, data is stored in the row format, correct? And non-clustered, okay. Here is the row format, and in this columnar there is a column format. Column format, it means for each individual there is a one column, means one column having the separate lib page. Okay, and it will let's say, yeah, there are five names, means let's say Sagar, Ajit, Anjit, then again Ajit, then okay, Ajit, and after that Sagar and Nilesh, then Hemant, then okay, sorry, Piyush. These are the names, okay, and I have to create the index on it, correct? So if we are going to create in a clustered index or a non-clustered index, so what it does, actually it will keep the name as it is, and in front of them there is a actual, first of all, clustered index. Here I'm going to use a cluster, okay, and here is the non-cluster. I'm showing you from the basic, that's why I'm taking too much time. Sorry for that. And yeah, it contain the cluster, means it contain the actual data. Okay, so it will grab the data very easily. Okay, and in non-clustered index, it contain the row locator or a key value. Row locator. Yeah, here we seen there is a, means either it having the clustered index, then that there is a key, correct, or key or a hash address, means there is a row locator, hash address, right? But in terms of the columnar index, there is a separate lib pages, means for all the items, means suppose there is a, yeah, Sagar is come, okay, Nilesh is two times, yeah, okay, three times. So for Sagar, there is a one page, and then there is a Ranjit, one page, then Ajit, one page. Sorry, yeah, Control C, Control V, and there is a again. Yeah, these are the three names, right? Then Ajit come. Okay, here this is it. Then there is a copy. Yeah, this is it. Then there is a Nilesh. Okay, copy here. Then there is a Hemant. Copy. Okay. Then Piyush. Piyush is available? No. Okay, here. Then Nilesh, yeah, copy at here. Okay, so these are the data. Means leap level contain the this such a data. And when we are searching the data, select star from employee where name is equal to Sagar. So only one leap page will call. Means there is a drastically improvement of the performance in terms of the large data, in terms of the data warehouse system. Means yeah, it is just means very simple 10 rows, so that's why you are seeing as a yeah very simple, but we have to make a sum, count, mean, max, average, aggregation operation on the such a column. Then in that situation, column store benefits a lot when there is a reporting information, so it will definitely help us. And because it that leap level contain the entire data about that column only, that is nothing but the column store index, and it in the background it will compress the data. Means let's say there is a enum operation, means for Sagar there is a 0 value, for Ajit 1 value, Ranjit 2 value. Okay, then Ajit again come 1 value, Sagar 0 value, Nilesh 3 value, because 3 is not come but correct. Hemant 4 value, Piyush 5, Nilesh, yeah, Nilesh is already available, right? Nilesh is the 3. So all the means in background this data is stored, and that data means for 0, 1, 2, 3, 4 and 5. So such a data is stored, and that particular metadata it knows, means that column store index knows, yeah, 0 means Sagar, Ranjit means 1. So based on that 0 it will go to that particular page and it grab the entire data. No need to save the Sagar entire string, it will compress that data. So that is the logic behind of the columnar store index. Are you happy about this? Means whatever the explanation, please reply me. Hello, are you there? Hi, hello. No any response? Okay, no problem. How to create the uh, uh, covering in sorry columnar index? So I have a syntax for that. Sorry, I'm going here. There is only one thing we have to mention while creating the table. There is a going to you small example about the create index. Yeah, same thing at here, means there is a ix underscore columnar or column store, it's a same term, don't be confused. Yeah, means create column store index on, yeah, it is the just name, right? Create index name on patient and first name, so I am going to create it on a charge, right? And there is a amount. Okay, and previously, first of all, I'm showing you there is a sum of charge. Okay, sum of amount. You can see uh, execution plan. First of all, here is the actual execution plan. I am adding it here and execute it. So in execution plan, you can see clustered index scan and what are the rows to be read and how much is the operation miss per IO cost, estimated IO cost. First of all, function println, and yeah, I'm copying it. Okay, and then next thing, I'm going to create the columnar index. Okay, here you have to mention only columnar. Execute it, and then let's see. Yeah, within a here there is a columnar index scan is operation is happened, and you can see because this is a very small data na, that's why it is very quickly, and you can't see the good performance changes. If there is a million or billion drop records na, then I can definitely show you, yeah, there is a performance is improved. um, Here there is a, if you see, there is a 95%. Oops. Yeah, there is a 79% and here is the 95%, correct? And yeah, it is miss basically targeting on the estimated IO cost. You can see there is a 0.51 and 0.00315. So that is nothing but the means enhancement means we can see the data very quickly, right? And because some uh, tables having the billions of records, when we are doing the summation or aggregation methods means count min max or means there are only two things are mostly important. One is the average and one is the summation, correct? So there is a billions of record and you have to gather that records in on a report. So at that time columnar index will be very helpful. But in normal index, it means normal OLTP system. OLTP means our normal day-to-day database. There is a um, means simple insert, update, delete operations are happening. But in terms of the reporting OLAP system, yeah, columnar index will be helpful. But in OLTP, it does not, because it is just in the background there are too much operations it is doing, right? Lip level pages separating it out, then compression methods is using. So we have to avoid that things on a normal OLTP. That's why we are not using for the OLTP purpose. Okay, then yeah, I forget filtered index. What is mean by filtered index? Let's say there is a situation means I post these on a LinkedIn as well. uh, this is the thing means, let's say your table ID, first name, middle name, and last name, whatever, and there is a email content, email column means someone is providing us email, or means there is a choice means it is not mandatory column, correct? So only two or three means there are a means there is a table and it contains the thousands of record, or we can say millions of record, right? And only five records, and for five records we are applying the index. So it is not the means actually when we are filtering the name means pf name at the rate gmail.com or a pf name to gmail.com. So it sorted out that things, and it will means null value is very large and actual value is a very low. In that situation we can apply the filtered index. Means let's say here is the means person is the table and email is the column. You have to make the email column as a unique, and that unique key or a unique constraint, it's your choice, and email is not mandatory, and it the application does not allow null value, right? Means sorry, application allow null value, sorry, it's my bad. And means application can say, yeah, your null is also allowed, right? So in that situation, we are allowing the null. And first of all, we are trying to create the non-clustered index. So I'm going to show you practically so that it will be helpful and you can understand easily. Yeah, create table person. Okay. So I'm, yeah, drop table. First of all, I think I already, yeah. Okay, I am, yeah, I included it in the replication. So I'm going to use the different database. Yeah, create table person. Okay. Oops. Okay. Sorry. And yes, here, what is our objective? So it contains, email contains multiple null values, right? And we are applying the unique constraint, means we have to make the values, means suppose that particular person having the unique email id, right? We have to maintain the unique and non-clustered index, so we are going to create it, correct? So right now that table does not have any data, that's why it applied. And when uh, we are dealing with uh, yeah, duplicate null value, right? So if we are applying the, means when we insert the data into these tables like a p up name, so it won't allow null value, it will say, yeah, please enter only one null value, because we applied the unique constraint on it, right? So I'm going to show you insert into person table. First of all, I'm dropping that, and then insert into person. And yeah, values, id first. Id is the identity, so no need to, yeah, last name. And email as a, yeah, 1pf@gmail.com. Okay, and go. First name. Okay, insert into person. Okay, the last column, then after that email is missing. First of all, I have to create the table, right? So creating the table, and then I am inserting the data. Okay, so one record is inserted, right? And let's say there is a one more thing, means I have to insert the second record. There is a first name 2 or a 1, okay, and there is a p of 1. Okay, the second record is inserted, right? And then next thing, I have to insert null for 1000 times. Okay, and first name 111, then 111 here, and then I'm inserting the null value, right? Then execute it. So okay, so 1000 times it's inserted. Then select star from, yeah, you can see there are 1000 records having the null value. And in this situation, we have to create the unique, we have to allow one email ID per person, right? And that contain the null values as well, right? So when we are going to create, so it will give us the error, means we can't create the null values for the multiple records, right? So how to avoid that? So here we have to apply the unique word, means there is a we have to, here is the constraint, there is a unique constraint for the email, right? And then next thing is the filtered index we have to create, right? So actual answer is this, means here if you apply unique in email, then multiple null values, right? There is another solution as well, but the right answer is this. We have to create the index on a, means if we apply this, so it will again create an error, means there is a unique email value, right? So the actual answer is, means for this unique non-clustered index, there is a person table on email ID column and where email is not null, right? So you can achieve two things, means there is a email should be a unique and it contain multiple null values, so that is nothing but the filtered index. So in that index there is a filtered clause, means there is a where clause is used, so such a index we can call it as a filtered index. Okay, I think you got the clear idea about the filtered index. And we seen index seek, index scan and table scan. Hello, yeah, can you hear me? Okay, yeah. So yeah, there is a index seek, index scan, and execution plan basics, means we already covered. And execution plan related things I will cover in a separate session so that you can easily understand, means how to see the execution plan. Means yeah, we already seen, but yeah, I have to show you in a detailed manner. Means there is a execution plan from how to read it. There is a right to left, okay, and then top to bottom. These are the two methods, means two things are important for that particular execution plan. Means let's say this is a very simple query, but in stored procedure there are thousands lines of code, and you have to read the execution plan where it is slow, or how to read that execution plan. So you have to read it from the right to left and top to bottom, okay. But yeah, I will show you, means about the each and every uh, means miss most of the miss when we are joining the two tables, so there is a inner join will occur. There are some means nested loop join, hash join, or there is a merge join, and these are the some operators of the execution plan. I will explain in the next or upcoming session. Okay. So after that, there is a yeah index seek, index scan, and table scan we already covered. Yeah, fill factor. Fill factor is nothing but the a percentage of space is available filled within the lib page. Correct. Means let's say there is a this is the lib page. Correct. And how much space is free means there is a 80% fill factor means 20% is data is 20% space is free for the means movement of the data, or means when we have to switch the data from one table to the another means one page to the another page, or there is a data relocation movement means when we are uh, dropping means when we are deleting in the data means let's say there is a one index and one index having the let's say table having the 1000 records, or in means that particular index contain that 1000 data, right? And we are deleting some data in between that, so there is a some uh, means fragmentation is occurred, right? And how much that particular page contain the data, so it will decided by the fill factor means 80%. It means yeah that page is occupied with 80 percentage of data, not more than that, and 20 percentage is free for the data movement. So that is nothing but the fill factor. And I think from the sys dot configuration we can see the fill factor value. Means select star from sys dot configuration. So yeah, you will get all the things, and in that you can see fill factor value, and by default it is the 100 because we are allocating the space for the 100 percentage, right? Means yeah, here you can see there is a fill factor percentage, so maximum it is the 100. We can set it to the 80% as well. And I one thing I forget to say, there is a in execution plan is basically dependent on the statistics. Means let's say there is an index or a column, right? Means table having the these two things means it having the index, it having the first of all it having the columns, and based on the columns we are having the index, right? And uh, on the basis of that there is a statistics it nothing but the means suppose let's say there is a one table employee, and in employee there are the employee name is the column, right? And in employee name and there are multiple values, so what are these values? So it that particular column contains the stats means it grab the data from that particular means here there is I will show you here best way. Patient ID, patient filter. Yeah, okay. And there is a statistics, and here you can see there is a multiple means ix name means we created the index, and here is the when we are creating the patient at that time in background there is a primary key is created, right? So index having the statistics and column having the statistics, right? So when and when we are executing the query at that time in background there is a execution plan, right? So execution plan is basically dependent on the statistics. Okay, means there is a column means if you say anyone yeah means what is the basics of execution plan is basically dependent on the statistics are dependent on the column or index. Okay. Yeah, spelling is incorrect at here. Okay. And after that, yeah, fill factor I explained. Heap table, yeah, means there is a that particular table does not have any index, then we can call it as a heap table. And one thing, yeah, suppose first of all, yeah, uh, physical read and IO read. Physical read, logical read. I have to explain you. Means let's say um, select star from patient, right? So you will get this data, and in the background here, set statistics IO on, right? And select star from patient where first name is equal to P of 9, right? So in this you will get the message, and it will show you, yeah, how many logical reads are happen, physical reads are happen. Physical read and logical read. Physical read means when means there is a where data is stored, correct? And that data is stored, we are fetching the data from that location. That is the physical read. Logical read, it means that data is available into the RAM, means local memory, SQL server memory. So if you see, there is a SQL server, and in there is a properties, and you are assigning some memory to the SQL server, correct? Means in terms of the, and what is the actual value? 80% avail memory is means uh, best means we can say best practice is the 80% memory allocate to the SQL server. Means let's say out of 16 GB is the my memory, right? Means my laptop memory, and out of 16 GB there is a 80% is allocated to the SQL server, and rest of the 20% will be vacant. Means there is a, yeah, we can maximize the up to the 80%, and if we may maintain here as a this memory, means out of this, means that is the 100%. So somewhere there is a large heavy operation are happening on the SQL server, so SQL server causing the issue, and in OS we can't do the anything. That's why we are saying, yeah, 80% to the SQL server, and 20% is doing the rest of operation of the OS, correct? And that is come into the here, means logical reads and physical reads, because that particular RAM or means in memory operations are happening. So that in memory operations means the logical read, and physical reads mean the we are reading the data from the disk. I hope you got the clear answer about it. Okay. And rebuilding and reorganizing index, this is the part of the index maintenance. Means index fragmentation, first of all we will see. Index fragmentation means, let's say, yeah, I have to show you, or I have to say about the one thing as well. Index background means, yeah, I will explain you first, and then we will come to here. Index background means, let's say we are creating the index on a table, right? Means on a particular columns we considered at that time, and when we are inserting the 5 records, so in the background index is also altering. Means it means when we insert the 5 records in it, so in the background that 5 records also updated in the indexes, right? Or if you delete the 5 records from the particular table, then index is also changing. Means whenever there is a insert, update, delete happen on the table, so means DML statement operation is happen on the table, at that time index is means changing, right? So that is nothing but the index background. And why it is important? means there is a table having the multiple indexes, so it is not the good practice. From insert point of view or a insert update delete point of view, means DML point of view, there is a minimal indexes on the table, but from reporting point of view you can add. It's your choice, because in index reporting point of view, yeah, you can retrieving the data on the multiple columns, right? Means that is the reporting database, and you can apply the multiple indexes while inserting the data with the help of SSIS package. At that time you can disable the index, insert the data, and then while retrieving the data you can means just re-enable the index, or I can say, yeah, it means a reporting point of view index are better. And whenever there is a DML operations, only important index should be there, because it is performing the operations in the background. If I have to show you one query so that you will get some idea. First of all, okay, this is the query, means read, write, seek, scan operations are happen on that particular table. So first of all, uh, I am going to use here patient table, right? And if you execute it, so it does not giving us the, okay, yeah, object property. I'm just giving the blank right now, database ID. Yeah, because no any operations. Yeah, here you can see there is a index operations are happen, and number of reads, number of writes, then user seek, user scan, right? And let's say patient is the exact table name, right? Yeah, then okay, I have to, is any filtered operation, okay. Oh, okay, that's why indexes, and okay, got it. So I'm just filtering at here. There is a index, right? This is the index, and I'm calling the another p up as a 900. So are you getting this 6,000, right? So previously, what was the index seek, and right now, yeah, we can check. Here is the patient. Yeah, where miss number of reads. There is a previously there was a 16. If I am going to again call the same index, means there is a ix, it is the number of times 7 times, right? And then again I'm 6,000, so 60. And if I'm again going to check, yeah, there is a previously there was a 7 times, and right now it is a 8 times, means that index is called in the background. Means if you are doing the select operation, insert operation, or delete operation, then there is a number of writes and there is a number of reads. It means we are selecting the data from the table. Got it? And this is the primary key, means it is the primary key or not, and this is the query for that. Okay. Yeah, and I will explain you shortly about this, but yeah, time is over. So yeah, I will create a separate session on the rebuild and reorganize index. And still you have any doubts, I will, yeah, I will try to comment on that. Yeah. Then please ask me. Okay then, bye bye.